Finding the domain of functions. One of the ways I describe domain for my students is you're looking for all the possible numbers that can be used for input that will make a function give you a true answer or right answer. So we have a function here, 3x minus 10. Let's try numbers like say x is 4. Then we'll try x is 0 and maybe x is negative 2. I want to put these three numbers in here and see what happens. So if you put a 4 in here, you get 3 times 4, then take away 10, which is 12, take away 10, 2. 2, hey, that's a legitimate answer. That means 4 can be used for input. Let's put 0 in here. We get 3 times 0, take away 10, which is 0, take away 10, and that gives you negative 10. That's a legitimate answer. Therefore, 0 is a legitimate input. Let's try negative 2. So it'll be 3 times negative 2, and then take away 10, which is negative 6, take away 10, negative 16. No problem with having negative 16 as an answer. So negative 2. So basically, we see that positive numbers, 0 and negative numbers, seem to work with this particular equation. What we're saying is basically any number on the number line can work in this particular equation as an input number. The way that we express any number that can be used is we say negative infinity to positive number infinity, which means all real numbers, that's a bad end, bad letter N. But this represents what we call our domain. If you can use any number, we say our domain is all real numbers. This is all the possible numbers that can be used for this particular equation. Okay, so we'll say domain for this equation is negative infinity to positive infinity, which means all real numbers on that number line here. Okay. Occasionally you'll get equations where there are numbers that will not work. That typically happens when the x comes in the denominator. So the way to find all the possible numbers here is we do this. We take the expression in the denominator, it's a negative 4x, and we say, hey, we don't want this to equal 0. So we solve for this not being 0. I know we're used to using equal signs, but since we're looking for domain, we're going to use a not equal. But they work just the same, no difference. So we're going to divide both sides by negative 4. Negative 4 divided by negative 4 on x gives us 1x. And 0 divided by negative 4 is actually legitimate. Now we have to be careful when there's division and 0 involved, because sometimes you don't get answers. But this time this does produce an answer. 0 divided by negative 4 produces 0. So this is legitimate. So we're saying that you can use any number except for 0 on the number line. So here's your number line, and here's where 0 is, and it says just you can use anything before 0, and you can use anything after 0, just can't use 0. So we would say our domain is this area right here of numbers, which is negative infinity to 0, but not including 0. And anything in this area you can use for input, which is from 0 to positive infinity, not including 0, and always parenthesis on infinity. So our domain is now this area and this area. Okay, let's do that again. All right, again, here we have a denominator that has an x in it, so we're going to focus on this. So when we say x plus 5, we don't want that to equal 0. And we solve for x. So subtracting 5 from both sides, we end up with x not equal to negative 5. So it means that we can use any number we want except for negative 5 for input. So let's draw the number line. and remove -5 from the number line. So it's an open circle. We're removing -5. That means that for input, we can use any number before -5, which is over here on the left, and any number after -5, which is out over here on the right. So we'll say our domain is anything in this area right here, which is from -infinity to -5, not including -5, and unioned with anything in this area, which is from 5 to +infinity. So we can use a domain of anything in this area for input. Okay, next. We want to find the domain of this function. So we'll take the denominator of 4x plus 2, and we'll say we don't want to equal 0. And then we're going to solve for x. So let's subtract 2 from both sides. This will give us 4x cannot equal -2. And then we'll take our 4x cannot equal -2. We'll divide both sides by 4. This will give us our 1x. And this right here can be simplified if I divide by 2. So this will be -1/2. Well, and so x can not be -1/2. So I'm going to say that here's my number line, and this is where -1/2 is, and we're going to put a little circle around it. So that means do not use -1/2. But we can use anything before -1/2 and anything after -1/2. So our domain is -infinity to -1/2, unioned with -1/2 to +infinity, and that'll be our domain.